Welcome to this Rethé session. This is the second of 4 sessions focused on guidelines and how to write the unusual sections of a certain track. In this session, we will cover the methods and materials section. I'm Elaine Nsoesie, a native Cameroon and a professor of a custom university statistical. I will share guidelines on how to write the materials in the method section in repeat. Let's get started. The materials and methods section, or the methods section as it is referred to in some fields, aims to present sufficient detail so that other researchers can reproduce the methods and analysis process. You might need to reduce certain steps in your analysis, but you do not have to state this in your writing unless that is a necessary part of the process. Reproducibility and replicability are 2 words that you might hear often. To reproduce your research methods means that I use the same data to produce your findings, while replicating your methods implies that I use a different data set to produce similar results. Both are important for scientific research. So think about how to write your research process to make it both reproducible and replicable. In some papers, you will see a material section while others have a data section. This is a section where you list the precise measurements and units of the materials used in your study. If you're using data on people, describe the population demographics and the type of data used in the study. Also, if people are involved, clearly describe the selection process, including informed consent, and include a statement on the Institutional Review Board approval of the study. Present the methods chronologically. Use subheadings. If possible, use subheadings that match the subheadings used in your results section so that readers can trace the analysis corresponding to the various methods. Be precise when reporting numbers, proportions, or any other measurements. State methods used in the study and why you selected the methods. This is important if there are other methods that you could have used. If you use statistical methods that are widely used in your field, you do not need to spend several paragraphs describing the methods. If you're using an advanced statistical method or a novel method, describe the method and include citations. Let's discuss the methods section of one of my papers titled Online Reports of Foodborne Illness Capture Foods Implicated in Official Foodborne Outbreak Reports. This paper involved an analysis of data from Yelp.com. In this first paragraph, we describe the data. Note that we include information such as the year and the number of businesses included in our data. Yelp.com is a business review website created in 2004. Data from Yelp has been used to evaluate the correlation between traditional hospital performance measures and commercial website ratings and the value of forecasting government restaurant inspection results based on the volume and sentiment of online reviews. We obtained data from Yelp containing de-identified reviews from 2005 to 2012 of 13,262 businesses, closest to 29 colleges in 15 states. 5,824 of the businesses were categorized as food or restaurant businesses. Next, we talk about the initial processing of the data. Note that we are referring to tables with additional information, but we do not include all the information included in the tables. We constructed a keywords list based on a list of foodborne diseases from the CDC and common terms associated with foodborne illnesses such as diarrhea, vomiting, and puking. Each review of a business listed under Yelp's food or restaurant category was processed to locate mentions of any of the keywords. 4,088 reviews contained at least one of the selected keywords. We carefully read and selected reviews meeting the classification criteria discussed in the next section for further analysis. In the third paragraph, we describe how we extracted relevant details from the data. Note that each of the sections includes a subheading to help guide readers through the manuscript. We focus on personal reports and reports of alleged eyewitness accounts of illness occurring after food consumption. See Table 1 for examples. We concentrated on recent accounts of foodborne illness and eliminated episodes in the distant past, such as childhood experiences. For each relevant review, we documented the following information, if reported: date of illness, foods consumed, business reviewed, and number of ill individuals. We describe additional analysis focused on bias and clustering of the data. Data bias could be introduced by false reviews from disgruntled former employees and competitors. Yelp has a process for eliminating such reviews. We therefore focus on identifying bias introduced by individuals with a large number of negative reviews compared to the median in the dataset using network analysis and visualization. If a reviewer had significantly more reports than the median, we could investigate the impact of including and excluding this individual from the analysis. We also identified and investigated restaurants with more than 2 foodborne illness reports in the same year, since most restaurants appear to have 1 or 2 reports, and because the CDC defines a foodborne disease outbreak as more than 1 case of a similar illness due to consumption of a common food. Now, let's review the methods section of a related paper. This one is titled Detecting Reports of Unsafe Foods and Consumer Product Reviews. Similar to the previous study, we start by describing the data. The subheading is data gathering. Note, we describe how we obtain the data from multiple sources and the years of data available. Our data consisted of Amazon reviews of grocery and gourmet food products and enforcement reports from the FDA. We manually downloaded FDA enforcement reports, which were available as weekly CSV files from 2012 to 2017. The Amazon reviews were downloaded from a public repository and were available for the years 1996 to 2014. The dataset is a collection of product data across multiple categories with a comprehensive gathering of product reviews for each product. The data consisted of the following information: reviewer ID, the Amazon standard identification number, which Amazon uses to identify products, reviewer name, helpfulness of rating, review text, overall rating, which had 1 to 5 stars, and summary of review and review time. Under the same heading, we describe how the data was organized. Our first project aim was to create a database linking Amazon products and reviews to product record data from the FDA. The most reliable way to match recall products present in FDA data with Amazon reviews was by using the item's universal product code, which is a number that appears on the barcode and uniquely identifies that particular product. The FDA enforcement reports often, but not always, contain the UPC or UPCs of the products being recalled within a larger text field. We use regular expressions to extract these codes, and in some cases where partial UPCs were provided, generated list of the possible complete UPCs from the partial codes. The next subheading is data processing and analysis. In this section, we describe processing and analysis steps chronologically. Our second project aim was to develop a framework for early identification of unsafe food products. In order to identify relevant product reviews, we needed to identify major reasons why the FDA issues product recalls. We use unsupervised topic modeling through non-negative matrix factorization and cluster analysis to broadly categorize recall reasons from FDA reports into 7 categories. Topic modeling is a traditional text mining approach which represents each document, in our case each review, by a weighted combination of a few topics. Each topic is represented by a small set of keywords. This subheading describes the final step of our analytical process. This is the step that answers our main research question. We applied several machine learning classification methods to the review text, title, and consumer rating to identify relevant reviews. Since food recalls only occur for a small percentage of products and usually for specific product batches, the dataset is highly skewed. The classification task is akin to finding a needle in a haystack. We explored the following standard machine learning classifiers for identifying unsafe food products: linear support vector machine, multinomial naive Bayes, and weighted logistic regression, with various approaches for addressing data imbalance. The multinomial naive Bayes is a very simple classifier which relies on the assumption that the features are independent. I hope these examples have provided you with some insights on how you can write and organize the method section of your paper. I want to end this session by talking about data sharing. Not all journals require or encourage researchers to share their data, but there are benefits to sharing all or some of your data. Here, I use data to broadly refer to the raw data and other materials used in your research. Publishing your data in code can lead to more citations and increased research transparency. You can publish your data in code as part of your paper or as a separate paper in journals focused specifically on data. Thank you for participating in this session. To learn more about Rethé, please visit our website.